So the second part of our talk today is going to focus on three types of quantitative research designs. Let's take a look at some data to see how qualitative and quantitative research differ. The slide shows an extract from a conversation between a mother and child of about 2 years old. Most of us in linguistics are quite familiar with this type of data. Now, how do we go about analyzing it? Well, we could start by considering the interactional structure, where there's a clear pattern of question-answer sequences. Or if we're focusing on first language acquisition, we might notice there's a lot of child-directed speech. The mother generally directs most of the talk at the child and also makes accommodations in her language to account for the child's rather limited language skills if you look at the questions that she's asking. We notice patterns and sequences. In other words, we notice characteristics and qualities of the talk. We're doing qualitative analysis. Now let's look at another way to analyze the same data. In first language acquisition studies, mean length of utterance, or MLU, has been used as a way to measure a child's language proficiency. So if we're interested in measuring how proficient the child is, we would first extract only the child's turns, then add up the words. 5 words in the first line, 1 word in the second, and so on, and we get the measure of MLU. Let's look at some other bits of data. Take some time to read these two excerpts from research interviews. You can pause the video while you read the extracts. Is it quantitative or qualitative? Now let's compare this with some other data on a similar topic. Now look at the data on this slide and compare it to what we saw earlier. As you can see, both sets of data are about similar topics. They're related to the perspective of language learners about speaking English. However, the data we saw on the previous slide gave us a deeper and more nuanced perspective of the individuals, what the individual thought about speaking English in their own words. In comparison, the data that we see on this slide represents the students' perspectives as a response to a given statement. We have the statements on the left, and the students' perspectives are presented as a numerical, in a numerical form, where it's just one number that makes up a total. So on the right of this slide, you can see the frequencies for strongly agree, agree, neither agree nor disagree, and so on. The examples we've just seen, the two different types of data and also qualitative and quantitative versions, show us some broad differences in quantitative and qualitative research. This table also mentions certain key differences. For example, while qualitative research is interested in discovering ideas, quantitative research may be more focused on testing a hypothesis. Qualitative research is concerned with observing and interpreting, while quantitative research is more focused on measuring and testing. In qualitative research, our data collection is more unstructured, it tends to be more free-form, but the data collection approach in quantitative research is generally very structured, as we saw in the last slide, with the students' responses to a survey. In qualitative data research, the researcher may be very involved in the research context, but in quantitative research they're less so, and it's seen as more objective. Finally, in terms of sample size, as you probably know, quantitative research tends to have larger sample sizes because one of their aims is often to produce results that can be generalized to other situations, whereas this is not a big focus in qualitative research. Let's compare the differences in the steps in the research process. So we've talked about the steps, right? Identifying a problem, reviewing the literature, up to collecting data and analyzing and interpreting it, which were listed by Cresswell. And if we look at qualitative and quantitative data, what are the different characteristics at each stage of the research process? We can see that looking at the purpose in quantitative studies, it is much more specific and narrow. the data collection is also very much pre-planned and predetermined, with very structured instruments. And analysis and interpretation of data in quantitative studies are generally mathematical or statistic in nature, and findings are often related to describing trends, increase, decrease, changes, comparison, and predictions. And the reporting is very standard and fixed, and would attempt to be very objective and unbiased, in the sense that we don't see much of the researcher's view and opinions. On the other hand, qualitative research is more exploratory in nature. The purpose can be very broad and often is written from the participant's perspective. In terms of collecting data, we may not have, we often don't have an instrument. It can be textual data, spoken data, image data, and a much smaller sample or size of data set. Text analysis is often focused on description and themes and looking at the meaning behind findings. The reports and the style of writing and how we report our findings in qualitative research is more flexible, and there can be a reflexive kind of nature in some types of qualitative research. Although I may not, I may not agree that it can be said to be biased, but in a statistical sense, maybe. But we do see more of the researcher's perspective when writing up qualitative research. Both quantitative and qualitative research methods show us valuable things. However, which approach we choose is determined by the context of our research, the kinds of research objectives we're aiming to accomplish, what our theoretical perspectives are as researchers. So let's take a closer look at quantitative research. In general, we can say that while qualitative studies are concerned with identifying patterns and structures and describing them, quantitative research is concerned with measuring how much, how many, or a degree of a certain variable or characteristic. One advantage of quantitative research is you can apply it to describe and compare large amounts of data, and this is often impractical with most qualitative methods. Data is analyzed using statistical methods, which can be divided into two types, which are descriptive statistics, which we describe the measurements and frequencies, and inferential statistics, where we use a statistical measure to see if there are any relationships between variables. Another advantage of quantitative research is that findings from a sample that is collected via probability sampling approaches can be generalized to a larger group or even to the population. This means that if your sampling and techniques are accurate and reliable, it's possible to say that your findings from a sample also holds true for the population. Generalizability is not an objective in qualitative research. In terms of methods, quantitative research takes a deductive approach, meaning that it starts from a theory or point of view, which is then tested against results. Theories also inform hypotheses, which are presumed relationships between two variables. For example, you can hypothesize that people who like the color red have high energy levels, and you can collect data and do a statistical test to see whether your hypothesis is right. There are also larger questions behind a researcher's choice to use quantitative methodologies. These are to do with your theoretical or philosophical stance about the nature of being and knowing. Remember the onion we talked about early on in the course. Quantitative research is mostly associated with positivist and realist stance, which take the view that reality exists independently of who is examining it and how it is being examined. So we take the approach that there is some truth that we can measure using quantitative methodologies. There's an objective reality that we can measure, and we can describe it in numerical means. This contrasts with the philosophies behind qualitative research, which tends to come from the viewpoint that reality is constructed and subjective depending on who is viewing something. There are three main types of quantitative research design, and we're going to talk about these in this video. We've got survey research or descriptive, we've got correlational research, and we have experimental or quasi-experimental. Theoretically, people divide quantitative research only into two, which are experimental and non-experimental. But for practical purposes and for how we're going to discuss them today, these are the three most common types of quantitative research design that are used. What do you think the main difference is between these three? So let's look at these three types of research designs generally. Survey research or descriptive research attempts to describe the current status of the identified variable or variables. As far as correlational research, you can see a clue to what it does in the image here and also the name of this type of research. The aim is to determine the extent of a relationship between two or more variables. So if you want to know if these variables are linked, then you would do a correlational type of study. And finally, experimental research, which includes quasi-experiments, which we'll talk about. It attempts to establish whether there's a cause and effect relationship between variables. We'll start by looking at survey research design, which is arguably the most widely used type of research. You're probably familiar with survey research as a consumer, citizen, and a student. We fill in so many different forms and surveys all the time. Most recently, when the university was collecting information to make decisions about how to conduct learning during the MCO, you would have filled in a few forms and surveys from the university. Surveys are popular with researchers because they offer a relatively simple and systematic way to collect information about the same variables from a sample of cases. Surveys can be descriptive or explanatory. For example, governments conduct surveys to get an accurate description of population size and characteristics, for example, gender, age, income level, health levels, and health behaviors. Repeated descriptive surveys taken over time can describe changes such as changing patterns of family formation and changes in employment levels. So this is the difference between cross-sectional surveys, which are taken just now, and longitudinal surveys, which are repeated measures of the same variable taken over time. Explanatory surveys try to account for the phenomena that they describe. For example, why are some people poorer than others? What are the reasons a student is anxious to speak in class? Our initial attempts to answer such questions are our theories, but these speculative theories require testing, and these theories will guide the design of the survey, the data we collect, and the way we analyze the data. In terms of data collection methods, surveys can be done using questionnaires, interviews, observations, and other methods. So what do you measure in through a survey? I'm sure you filled in some surveys before, and often they're used to measure attributes, certain types of behavior, knowledge. What do you know about COVID-19? What are your beliefs about language learning? What are your attitudes towards something? Do you like or dislike this movie or this bar of chocolate? But we can also use it to measure features of language use when we do survey research. Now, this doesn't mean we give out a questionnaire, but we use a particular form or an observation form, and we note down the frequency of certain types of pronunciation, certain types of words. You may also use a sort of survey principle to analyze language data, and you count the features of language use in a certain context. For those of you interested in language learning and teaching research, surveys are often used to measure individual learner differences like motivation, beliefs about language learning, and so on. So what happens with these data that we get? We process it with statistical measures. So we often report frequency, which are numbers and percentages. We have this measures of central tendency. So what are the main averages or means and modes, or the most common types of numbers in the data? And we also look at the difference. How big of a range is there statistically in the data? What is the minimum and maximum measure? What is the standard deviation? That will show us how much variance there is in the data. So what do we measure in survey research? Well, we can measure things like attributes, behavior, knowledge, beliefs, and attitudes. I'm sure you've filled in these types of surveys before, asking for your age or your gender, which are attributes, weight, languages spoken, nationality. You might have also filled in surveys about behavior, how many times you visit a particular shop. You can also collect survey data by observing people and ticking certain frequencies. Knowledge, we have quite a lot of surveys that look at people's knowledge about certain subjects. For example, recently during COVID-19, there are a lot of surveys to look at our knowledge about SOPs. Beliefs as well, which look at what people believe to be true about something. And attitudes are related to whether we like or dislike something, whether we evaluate something positively or negatively. And I'm sure you have filled in surveys that have asked you to um, rank something or say whether it's good or not good. There are other things we can look at, for example, features of language use. This would require observation, and you might tick the frequency of certain pronunciations or words or interactional features in order to count them on an observational survey. In language teaching research, often surveys are used to measure individual learner differences such as motivation, attitudes towards certain languages, and language learning beliefs. What do we do when we've collected these things? We apply statistical measures to describe the data we collect. These can be frequencies, which are how many of a certain type of variable were shown, or percentages. They can be measures of central tendency, which show what are the main or most common or average types of numbers in a data set. And they can be measures of variability, where it shows how much variation there is in a data set, which are related to minimum and maximum or standard deviation. Let's look at some of these examples. So a mean is a measure of central tendency. You would add all the numbers together. It's basically an average, and divide it by the number of samples you have, and you will get the mean. Another measure of central tendency is the mode, and that is the most common number. So if most of your participants respond with 3, neither agree nor disagree, then your mode is 3, like in this example. You also have the median, or the middle number. So you organize all your data in order, and then you see what is the middle number. And in this case, the median is 4.5. So these different statistical measures give us a description of what is in our data. Let's look at some example research objectives for survey research. So in the first objective, this is for a study that wants to examine whether one particular type of pronunciation is more common. So this context is about the pronunciation of the word air, which means water. In standard Malay, it's air, but in northern dialect, it's ayah. So a researcher might have this objective to identify which pronunciation alternative of air or ayah is more common among youth in northern Malaysian states. So they might observe a group of youth talking and note down and count the frequency of each pronunciation and then tabulate it to compare. Another example is to describe the types of grammatical errors made in theses written by linguistic postgraduate students. So here the researcher may analyze the thesis, categorize and count different types of errors, and then present the findings in terms of which types of grammatical errors are most frequent. The third example is to measure the frequency of miscommunication in online classes for Year 5 students at an Indian primary school. In this situation, the researcher may observe many classes and count the miscommunications to get a measure of how frequently these miscommunications occur. Finally, we have a bit of a broader type of objective to explore the factors behind high diabetes rates among Malaysians. So maybe here they could look at data and look at different variables and see which variables seem to be highly frequent in the data of people with diabetes. How do we turn these into questions? So these are very narrow objectives, not necessarily, an objective is not necessarily always narrow, but in this case, you can convert these are imperative statements for objectives, and you can convert them into questions. For example, the first one would be, which pronunciation alternative of I is more common among youth in northern Malaysian states? The second one would be, what types of grammatical errors are made in theses written by linguistic postgraduate students at UM? How do you convert the other two into questions? Why don't you try it and we can talk about it next week? Let's move on to correlational studies. Generally speaking, correlational studies aim to describe and measure relationships between variables, but this shouldn't be confused with cause and effect relationships. Just because we find that A and B are linked, it doesn't mean that A causes B to happen, or B causes A to happen. However, the finding of correlational studies can be used to predict outcomes. Unlike experimental studies, the variables in correlational studies are not manipulated. The researcher does not alter one of the variables. The first thing you want to identify in a correlational study is whether a relationship exists between two variables. If there is, then you would look at the direction of the relationship, whether it is positive or negative. You can also identify the form of the relationship, whether it is linear or non-linear, as well as the strength of the relationship, whether the variables are closely or weakly linked. Data for correlational studies can be collected by observation and survey, or it can involve data from an archive. One example is when doctors use medical data over the past few decades to identify, for example, whether certain eating habits or certain occupations are linked to specific diseases. So that is why you might see certain medical data saying something is linked to something. It does not say that something causes something, because that is a lot harder to demonstrate. These are scatter diagrams which show different correlational patterns between the score for two variables. The main result of a correlation is called the correlation coefficient, or R. It ranges from -1 to 1. The closer R is to 1 or -1, the more closely the two variables are related. If R is close to 0, then that means there's no relationship. For example, in the figure below, we can see there's no correlation because R is 0. As you can see in A, when one goes up, so does the other. So A shows a positive linear relationship. In B, we can see when one goes down, the other one goes down, so B shows a negative linear relationship. To wrap up this section on correlational design, let's take a look at some example research objectives for correlational studies. If you recall the first example for survey design, it was to see which pronunciation of I is more common. However, for correlational research, the objective would be more concerned with identifying a link. For example, if there's a relationship between age and the pronunciation of I. So here we have two variables. One is age and the other is pronunciation of I. Now think about how you would measure these two variables in terms of a number. Likewise, instead of just describing students' word order errors in the thesis, in a correlational study, we would want to see whether a student's first language is a predictor of their tendency to make word order errors. So we have two variables here, the type of first language and the frequency of word order errors. In terms of the miscommunication during online learning, we might want to see if there's a relationship between the frequency of miscommunication, which is one variable, and students' final English exam scores. So we might collect the frequency of miscommunications in a class, and then also the students' final exam scores in the class, and do a correlational analysis to see whether there is any relationship between these two variables. Another example is to see whether there is a relationship or there's a link between eating lots of fruit and having high blood sugar. So what are the two variables here? One is how much fruit a person eats, and the other variable is high blood sugar. So let's say we identify there's a link between eating lots of fruits and high blood sugar. This doesn't mean there's a cause-effect relationship. It doesn't mean that fruit causes high blood sugar or high blood sugar causes people to eat lots of fruit. It just means that these two variables are linked. So how do we turn these correlational objectives into questions? If you notice, different to survey, these are more like yes/no questions. If there is a relationship, so as a question we would turn it into, is there a relationship between age? We might focus it a bit more looking at what is the direction of the relationship between age and pronunciation, or to what extent is there a relationship if we want to look at strength of relationships. I would suggest that you try turning these objectives into research questions so that you get some practice of constructing research questions for a correlational study. The third and final type of quantitative research design that we're going to talk about is experimental design. Now, often when people think about research, they think about scientists in the lab doing experiments, but experiments are conducted in many social science fields as well. Experimental research attempts to ascertain whether there is a cause and effect relationship between two or more variables. In other words, whether an independent variable causes a change in the dependent variable. There are different kinds of experimental design, but the gold standard in experimental design is what we call true experiment. There are three features of true experiments. The first of which is manipulation of the independent variable. Let's say a teacher decides to do an experiment to see which teaching method is the most effective in improving students' final exam scores. Here, the teaching method is the independent variable, so the teacher can manipulate it either by introducing it to the class or by increasing or decreasing her use of a particular method. The second element of true experiments is randomization. We talked about randomly selecting participants in our discussion on sampling techniques, but in experiments you must also assign participants to certain groups at random. Talking about groups brings us to the third feature of true experiments, which is comparison. This refers to having different groups to compare their results. To continue with the previous example, let's say the teacher decides to introduce a new method with one class, but continue with the current method of teaching in another class. The group which receives the new method or the manipulated variable is called the intervention group, and the group with no change is called the control group. There are also other experimental designs. For example, pre-experimental designs are non-randomized and they're considered less robust because they're missing certain elements of true experiments. A single case design is also often considered an experiment. So this is not really like a case study. It only has one participant, but this one participant will receive an intervention and the dependent variable will be measured. For example, you have a student who is struggling, you expose them to a particular teaching method, and you measure their language proficiency over time. We also have quasi-experimental designs where participants are put in control or intervention groups but not randomized. In terms of measures, most common measure used is pre-test, post-test. We measure the variables that we are interested in before we give the intervention, and then we measure them after we give the intervention. How do we see whether there's a change or not? We do statistical tests. So there are various statistical tests that are used to see whether there's a change in the pre and the post-test, and some of the examples are listed here. This slide shows an overview of a true experimental research design. As you can see, participants are first randomly assigned to either group A, B, or C. Group A is looking at intervention A and group B is looking at intervention B. Secondly, they are pre-tested on the dependent variable. So they all undergo a pre-test. Typically, on the basis of the pre-test, we will perform a statistical analysis to see whether there is any pre-existing difference between the experimental groups, which are group A and B, and the control group. Third, the experimental groups receive the experimental treatments. As we can see, group A receives treatment A, group B receives treatment B, and the control group often receives no treatment. At the end of the treatment period, participants in both groups are tested on the dependent variable, and the participant in the control group is also tested on the dependent variable. The scores are then statistically compared by means of the independent sample t-test, Mann-Whitney U-test, one-way ANOVA or Kruskal-Wallis test. Now that we've covered some basics about experimental research design, let's quickly look at some research objectives that could be addressed through experimental design. Let's start with the topic of pronunciation. For an experimental study, we want to look at a cause and effect relationship. So an example would be to identify whether the way a person pronounces certain words affects the listener's perceptions of his employability. So we may have to do an experiment or simulated type of interviews, and we get certain participants to pronounce words in a certain way and certain participants to pronounce words in other ways, and we compare these groups in terms of the dependent variable, which is the listener's perception. So we would also collect data, quantified data on listeners' perceptions of employability and see whether there is an effect in how the listener views the person in terms of how they pronounce certain words. Another example would be here in this study that wants to see whether motivational SMSs can encourage students to exercise more. So here you might have a control group that doesn't receive any SMSs, and you may have an experimental group that receives motivational SMSs. Before you start sending the SMSs, you would collect data from both groups to see how often they exercise. And then after a certain period of sending SMSs, you would then collect data again from both groups to see whether there's been any change in how the control and the intervention group exercise. That will allow you to calculate whether the intervention of the motivational SMSs is effective to encourage the intervention group to exercise more. Another example in advertising here is whether bright colors in online advertising can cause an increase in eye movement. So here you would measure the variable for here is the use of bright colors, and the second dependent variable here is the eye movement frequency. Finally, on the topic of diabetes, an example of an experimental study would be a study that aims to compare treatment X and treatment B in terms of how effective they are in lowering the blood sugar levels of a group of patients compared to those on old treatment. So this type of experimental design will be very similar to the figure that we saw earlier. where you've got two types of interventions or treatment, and then you have a control group, and they will go through pre-test and post-test, and we can calculate whether there's a change in the treatment groups and which treatment is particularly effective. So to practice some of the things we've talked about in this week's videos, here's a self-learning activity for you. Think about your research idea that you've been working on from week 1 and consider how you could design this as a quantitative study. Think about whether you could design it as a survey study, a correlational study, and an experimental study. One useful way to start thinking about what variables could be measured in relation to your research idea. Now, for each of the types of research design, write one research question and share your answers in the week 6 channel. Don't worry about making mistakes. This is all a learning process, and these are quite tricky things to do. So I hope you won't be shy in sharing your 3 research questions in week 6 channel under this video.